Hi guys, welcome to Tech Geek. So today we are back with the daily Leetcode challenge problem. That's my calendar one. That's a Leetcode medium question, Leetcode medium 729. Basically, this question belongs to fan questions. If you have seen kind of merge interval questions, it's similar to that. So White asked if you know how to approach this concepts and a little bit of harder level if you talk about, because it's not easy for everyone to get through what they are actually asking. So before beginning, I'd like to request you to please like, share and subscribe to my channel. Go visit the help sheet, that's hiring help sheet for various companies which I have shared. I'm working on other companies too. We'll be sharing it very soon. For the batch of 2022 and 2023, I have shared multiple openings for the placement series. Do join that. If possible, connect on Telegram and LinkedIn for further updates, because many job openings are in there that could be posted as video. So I just share the link on my channel. Okay, let's see what the question says. Okay, the question says you have to implement a program to use as your calendar. Now, in a calendar, what we do, we can add an event. Okay, so we can add an event, but making sure that on adding that event, okay, there are no double bookings. So double booking is what? Double booking happens when two events have non-empty intersection. Okay, now we'll explain you what they mean. Then the event can be represented as a pair of integers that start and end. So for any duration, you need the starting point and the ending point. That represents a booking, and if you have a half open interval, so you must have studied about the closed intervals and the open intervals. So it's similar to match. So open interval refers to that we don't consider the ending number. Okay, so that's what they want to say. So what all we have to implement? We have to implement my calendar class, where my calendar initialize, that's a constructor, initializes a calendar object, and a function that returns true if the event can be added. That means there are no double bookings, or return false. Okay, that's what we have to do. We have been given some set of examples, so let's consider the example given to us is this. Okay, this is the example that's given to us. Now if we talk about directly what could be the possibilities that could make up. Okay, so you can see for the first one, as initially you don't have anything. So if you don't have anything, then obviously you can, let's have this somewhere like this. Okay. Initially you don't have anything, that means from 10 to 20. Sorry, yeah. From 10 to 20, you were not occupied, so now you occupied yourself. Okay. Comes to the second part. The second says 15 to 25. Now 15 to 25, you can see that this part is already occupied. So that means you are having a collision or double checking. So this cannot be added. This can be added. Then coming to the third one, 20 to 30. Now you can see this 20 to 30 is still empty. So you can add this. So that's what we need to do. We need to maintain a particular order. So what we can do is we need to maintain a list of intervals. Okay, and we have to check for any two intervals. Let's say we have a starting point and we have an ending point. We have a starting point and ending point for two events. We have to check they should not conflict. They should not conflict in what conditions? That means they should not conflict if starting one is always, oh so sorry, yeah, we don't want any collision. So collision won't happen if your ending point of first, okay, is less than or equal to the starting point of the second. Let's see, we have one more, 5, 10, 15, 20. See this. So in this, obviously no collision would be there if we talk about these two. So how is this possible? The ending point, that's E1, is always less than or equal to starting of 2. That's your basic concept. Or we can do the opposite also. Let's say we have been given this first and this next. Then in that case, we could also say if E2 is less than or equal to S1. So that's what we need to check. Okay. Somewhere we can say that we need S1 to be less than E2 and S2 to be less than E1. If such things are there, that means conflict will occur or double checking would occur. Double would. So that's what could be the conditions. But if we do it like rigorously, we'll check 2, 2. So obviously for this case, our complexity would go with order of n square, because we are comparing two sets again and again. That's what could go on. And a complexity of space complexity will also be order of n, because we are comparing each and every time and storing it. So that's not an efficient way if we go up. Okay. See, the one which I explained is somewhere like this. We'll create a list. For this list, we'll run this loop and check for this particular element that for every element it's a of 0 and start, and if less. So this is a modified version that will go off with order of n, because this time we're not running a loop inside loop. We are just checking for the maximum value of the start and the start available. So the collision that could be possible, and here the ending point is for the minimum and the end. Okay. Then comes the second and a quite good approach, that's for the tree maps. You can see a tree map is always there. So what we'll do, we need to store these elements, or you can say the duration, in a data structure that will keep the element in sorted order, very first thing, and we'll have the fast insertion. So why we are using tree map, the reason is very first sorted elements and second is fast insertion. So somewhere a time complexity would be improved. That's what we have to do. So we'll choose this tree map for the same things. Now tree map, what we'll do, we'll check for the keys. Okay, starting of each interval, that's we have start and end. We'll check the previous whatever we are getting, the start and end should be less, and similarly for the next one it would be same. So as you can see, we are checking for the floor key and the floor entry and the ceiling entry, right? So what is a floor entry and a ceiling entry in a tree map? That's what we need to know right now. See, what we are doing, we are checking that the floor entry of the start is not equals to null. So floor entry is actually giving us the key value mapping, that is with the greatest. This gives the greatest and this gives the smallest. Okay, so the same way we were trying to get the method dot max using a loop for I equals to 0 to I equals to n to I less than n. The same thing, instead of writing this loop, we can directly use this function. So this will give us the greatest value that's greater than or equal to, and if there are no such keys, so it will return null. So we'll check if it's not null, and secondly, if that value is greater than start, and the same case the smallest value should be less than n. So if these cases occur, that means there are no collision. If no collision, that means it should be added to the tree map and return true. So when we do this, so when this particular condition is being followed up, okay, so what is the problem, or what's the time complexity improved? So as we said, we have faster addition, that's insertion, right? So for this case, the time complexity goes up with order of n log n. Instead of n square, we have improved it to order of n log n. What is this n log n goes up with? The insertion, as we said, will take order of 1 time. Okay, and for each new event, okay, searching this part that goes up will go up with order of log n. So n insertions, n into order of 1, that's order of n, then order of n. The space remains the same of order of. So that's what the complexity would go up. I hope the solution is clear. Even if there are any queries, do let me know. I'll be there to help you out. Simple request to you always, please share my channel, my content with your friends, colleagues, and your juniors. It would be great help. And if there is anything you'd like to know about any recruitment process, any interviews, do let me know. I'll be there to help you out. Till then, keep following. Thank you.